I hope my voice is audible to all. Hi. Um, so I hope yesterday everyone could able to execute the job. And today mm, we'll be talking about one of the most interesting action on top of Hadoop environment. Indeed, I can say everyone might have even experienced these sort of um, jobs or these sort of actions in your regular life. I hope, as I specified yesterday, let's say that I opened a bank account, let's say I just got registered in Flipkart. And so Flipkart will have all my previous purchase history details. It'll have my age, my gender. It'll have my place, my current location, my mobile number. It'll have everything. Indeed, I can say, basing on all these things, because if you go for something called as machine learning algorithms, the most sophisticated way of generating the recommendation engine, there is something called as user similarity and item similarity. We'll call it as clustering. So in that clustering perspective, similar people who are of the same age group, the people of my age group are about 30, all the people will be grouped together. The people who are of above 40 will be grouped together. So let's say they just grouped up all those things together. And so basing on the majority of the people, let's say all the people who are in the age group of above 35 like the items like jeans and watch, and majority of the people also liked shoe. So when I purchase something items like jeans and watch, I may get a recommendation that I might also like shoe. So we'll call this as user similarity. Basing on the users, we'll just recommend the things. Projected if they have all these things, projected if they have all much details regarding me, then they can generate me as very sophisticated, I can say very high-end recommendation. But let's say I'm a regular viewer of Facebook, not a buyer of Facebook. I usually open Facebook, Flipkart. I usually open Flipkart and I usually surf the things. I'll not purchase anything. And even I not got registered, let's say. Even then, if Flipkart could able to generate me a very sophisticated recommendation engine, because Flipkart know that I don't purchase them, but still if Flipkart could able to generate a very good recommendation for me, then obviously Flipkart can hold me for a long time on their website, which will increase the site traffic and generate some revenue. So even that is also one of the advantage. So if the users are registered users, then no problem. We'll have all the details, and so we can generate the recommendations at a very good level, in a very better level, advanced level. But if the users are unregistered users, just only the viewers, then if I just want to generate the recommendation engine, then that's a tricky task. Where for that, we need to trace out the click streams basing on the majority clicks made by the users. What are all the continuous consequent items that are being used by viewers? Majority of the people, those who are viewed something like t-shirts also viewed goggles, and those who have viewed goggles also viewed watch. Those who have viewed watch also viewed something like body spray. So if these sort of things were being captured, and if they could be traced out, then these analyzing the clicks, whatever a particular user was being performed, we can call it as click stream analysis, and we can analyze them, which will in turn increase the revenue. So here you can see the URLs. These are all the URLs which I shared. Now I'm sharing you what type of output that I need to have. Just 1 second. What type of output that I need to have. I'm just sharing you that. So let's say my required output is like this. That means this should be the reducer output, I can say simply. Right. Reducer perspective, I need to get the output like this, where I should have URL1 and something like URL6, and how many times this combination got repeated. URL2 and URL7. How many times this combination got repeated? URL5 and URL2. Even how many times this combination got repeated? And URL4, URL1. How many times this combination? So I can say simply how many times these combinations were getting repeated. So basing on that, I can just pop up with some recommendation where this will be given as input to the BI team. Indeed, I can say the intelligence team, data scientist team, where they'll be working on top of applying the recommendation engines, and they can just even get the sophisticated recommendation, where they'll go on with the item based similarity, not the user based similarity. They can get the better results. So this is what I need to get the output. This is how I need to get the output, indeed, I can say. Now, obviously I need to talk about the input as well. So I'll have the URLs, URL2. These are all the URLs clicked by the users. URL2, URL6, like this. Something users are clicking like this. These are all the clicks made by a user. And the other user clicked like this. So I need to trace out the most consequent repetition of the URLs. That means I need to get the mapper output like this. This should be the mapper output where I'll say URLs, the most consequent URLs, and with one as I'll be awarding one for each and every. something like this. And so after you got so many records like this, they'll undergo the shuffle and sort phase. Let's say the shuffle and sort phase output are like this. And which will be given as input to the reducer, where you'll be performing some aggregation on top of those list of ones. So in this flow, mapper output, we need to design the most consequent URLs as the mapper output. And let's discuss how we can do that. If you observe, the mapper output key is text, mapper output value is iteratable. Reducer output key is text, reducer output value is iteratable. So we have that. So let's perform this action now. Let's discuss how to perform this action and how can we have those things. Am I clear in the flow or anything unclear in the flow? Anything unclear in the flow? Any question?
No, Vignesh, we are good.
Right. Okay. I did not see that everyone is in mute. So I just unmuted yourself. Kindly mute from yourself so that if you have any question, you can kindly unmute yourself and you can shoot me. Just kindly mute from your side, please. Right. Thank you. So now let's talk about the driver class, where here the driver class extends configured and implements tool, the same old implementation. Extends configured and implements tool, where here you are implementing the run method, where you define two variables, input and output. Previously, whatever the arguments of 0 and arguments of 1 you have, you directly passed them here, but we just made some modification in this. So if arguments length is equal to 2, then input is arguments of 0, output is arguments of 1, only that. Else you'll pop up with some message which will be displayed on the error. And here the same old approach. So you'll be creating the job conf object. Just 1 second, just give me a moment, 1 minute please. Please let me attend an important call, please. I'm sorry. So here we can see the job conf object as usual created, where acquiring the configurations by using the get conf method and setting the job name, nothing but the class name, and input path. Previously we passed arguments of 0 here because we already initialized arguments of 0 to input, so we are passing those strings input and output. And mapper class is link mapper dot class, reducer class is link reducer dot class. So here it is link mapper and link reducer, and mapper output key is text, because if you observe, mapper output should be like this. Mapper output key should be URL combination, which is nothing but text, and mapper output value should be 1. That's what we just went on with. So mapper output key is text, mapper output value is iterable. Similarly, reducer output key is text, nothing but URL combination, and reducer output value should be iterable, sum of ones, and triggering the job by using the run job method. And as usual, the same implementation of the tool runners run method, the same part. So if you observe, moreover, you'll find the driver class did not change anything. Whatever the driver class we discussed yesterday, the same driver class. You'll not find any difference in driver class. That's what I specified. Driver class will have the same sort of flow. Indeed, it will have the same set of configurations. It will not usually change. So let's talk about the mapper class, where the exact logic relies on. So let's talk about it. Where we know input to the mapper will be like this. So these are all the URLs. Let me just make them simplified to understand. So input to the URL will be like, input to the mapper will be like this. You'll have something like byte offset, comma. So this will be the input to the mapper. This will be input to the mapper, where key equals to the byte offset, which is 213. Value equals to all those list of URLs. I mean the sequence of URLs. Just like this. Now let's consider a string yes, which is equal to value dot toString. So you're just converting these URLs into string type, because value is of text type. So definitely we need to convert it into the string type, and then only we can perform all those actions. So that's what we did. And we declared a variable last equals to null. Anyways, we'll discuss why we declared it and what was the major reason behind that. Now S split it according to space. That means splitting at each and every URL like this. Splitting like this. And you are capturing each and every URL by something called as link. If link length is greater than 0, yes, this condition is true. Link length is greater than 0. And here you are mentioning if last not equals to null. We ourselves mentioned last equals to null. So if we say last not equals to null, that means null not equal to null, which is false. So the control shifts from this part to this part, where we mention last equals to link. That means last equals to URL 23. So we made last equals to URL 23. Now again, when it iterates for the next time, your last equals to URL 23 currently, that means nothing but link. For the next iteration, this will iterate to the next element, where if link length is greater than 0, absolutely URL 22 is greater than 0, so again it will come to the next statement, last not equals to null. Yes, it is URL 23 which is not equals to null. Now at the output collector perspective, we are creating a new text where last comma link, that means last comma link is URL 23 comma URL 22. Awarded with 1. And again, here you are making last equals to link. So last equals to link is nothing but URL 22. Right. Again, when the loop iterates for the next time. If link length is greater than 0, URL 5 is greater than 0, and last not equals to null, where URL 22 is not equals to null. So again, new text of last comma link. That means you'll have 22 comma 5. Like this. And so on, will capture the consequent URL combinations awarded with 1. But definitely after shuffle and sort, we'll have the data sets like this, which will be in turn given as input to the reducer. And reducer perspective, if you observe, we need not to change much, because reducer we need to just perform the aggregation part only. So that's what we're just trying to do here, where link reducer extends MapReduce base, implements reducer, the same old implementation. Text iteratable, because input is text, which is nothing but URL combination, iteratable list of ones. Output will be text and iteratable again, which is URL combinations with sum of ones. And here we are implementing the reduce method, public void reduce, where text key, because if you consider the input to the reducer, you'll have things like this. Where key equals to and values equals to. And we declared a variable combo count, while values dot has next. Initially cursor will be at the 0th position, so it will move to the next. So values dot has next will return true because it has the next element. And here you're capturing the next element as values dot next, which will be nothing but 1, and you are incrementing the combo count with, which is nothing but integer. So you're using get method to convert the iterable type to the integer type, and you are incrementing it. So again, currently I can say combo count is 1 for the first iteration. Again, while values dot has next, cursor will be at this position. Yes, it has the next element. So again, values dot next will give you 1, where it will again increment, and it will be 2, 3, 4, and so on, the sum of it. So the same reducer logic indeed gonna work here, but now the logic changed at the range of mapper. That's what we just made. So the logic changed at the range of mapper, at the range of reducer, same, and driver always remains the same, irrespective of the map reduce jobs. You will not find any much difference between the driver classes. Driver classes will always remain the same, but whereas mapper and reducer gonna change slightly for each and every iteration. And this is about how we can just generate the recommendation. We'll see the output by triggering the job, and even we'll see how to kill a map reduce job which was running on. We'll even talk about that today. So any questions so far, or anything unclear till this moment? Anyone can unmute yourself and you can shoot me, please. Yeah.
Vignesh, I have one question in the previous file that we mapper file.
Okay, just 1 second. Yeah, please. Here it is.
Okay. Okay. Here we define the condition like where if last not equal to null. Why every time like we need to check the last value? Like is it a like condition to?
No. We're just making for the first iteration because we need to have the comma separated URLs, right?
Right.
We need to have the comma separated combinations.
Right.
So in order to get that combination, we declared a variable called as last equals to null, because for the first iteration we'll not have any second element, right?
Right.
So what we did is we declared a variable last equals to null, and link is nothing but, let's say, URL1. Something, there is some data in the link, right? There is something in the link. And when I say link length is greater than 0, yes, link length is absolutely greater than 0. Last not equals to null, because if I just eliminate this statement, if I switch on to the output collector, there is link, but what should be the very next URL? So for that I require a partial variable which will capture the temporary storage of the current link, right?
Okay.
For that we defined this logic. That's the major reason. You have to get the URL combination only for that.
Okay.
Yeah.
Vignesh, maybe if you open the input file once, I'm not able to recall what we had there. If it had the delimiter already has comma in the log file or whatever we have.
No, in this you'll have
it does not have. Okay.
Always you'll have the space as delimiter, because any URL will not have spaces.
Yep.
You might have any other things, but any URL will not have any spaces. So space will be the delimiter by recorded. Whatever the click you made will be space, and tab will be the delimiters usually.
Okay. So we have 2 URLs in one line, I think, before the line break.
No, not like that actually. So if I make
space?
Yeah.
Okay.
Always it will have space as delimiters and all the stuff.
Okay. So this is what we are trying to get there as an input, and then we are looking for the space and the null in the end. Okay.
Exactly.
Okay, good.
Yeah.
Thanks.
Right. We'll do this enough. We'll execute it. Am I clear or anything unclear? Please kindly let me know if anything unclear. it's
So
fine,
Vignesh,
yeah,
the
please.
most of the time, if the driver is the same and mapper, all the imported files packages are the same, it's
Mhm.
just that in between that logic
Logic,
is the only part changing, right?
obviously, yes. Only the logic will change. For
Yeah,
each and every
and
letter, we're gonna change logic accordingly.
yeah,
Yeah, please.
and the main function what where we invoke the whole thing is from the mapper only, right?
No, no.
From the
We have the
driver,
main method in the driver class, right?
driver, yeah,
Main
okay,
method will be in the driver class,
okay,
but only the logics will be present in the
the mapper,
map
yeah.
method and reduce methods only.
Okay. And when the shuffle and sort, right?
Mm.
I mean, from the mapper, when the logic is implemented, after that, the shuffle and sort, which is in the, I mean, automatically invoked, right? We don't write anything on that. And
Yes,
then,
absolutely.
yeah,
Shuffle and sort
and
perspective, it's the default phase, please.
okay. Then where are we invoking the reduce? Is it,
In the reducer method, right?
yeah, but that is
And
called,
once after mapper got finished, in the driver class itself, we mentioned what is our reducer class, right?
okay, got it, got it, got it.
Yeah,
Thanks. Thank you.
right. Can I know whom can I make as presenter? Anyone, please, so that we'll trigger the job. And I forwarded this. I forwarded the complete code.
Vignesh, we haven't got this one.
We did not get that. Okay.
Yeah, we didn't get.
Mhm. Okay.
Only we got like yesterday's.
Right. I got it. I'll do one thing. I'll just trigger it on my virtual machine. Okay. Let me just trigger it on my virtual machine, and later just kindly trigger on yours as well. Okay. Just triggering it here. Just let me open the virtual machine.
Are you triggering your machine instead of sharing on anybody's or making presenter?
Sorry?
Are you,
No, no. I'm just making it on my virtual machine.
okay.
Yeah, because as you shared that you did not get the code yet. So
Okay. For that sake, okay.
yeah, well, it's consuming a lot of time actually. Hmm.
Meanwhile, Vignesh, a
Yeah,
general
please.
question.
Please.
In real world, in projects, which is like mostly preferred or which is that mostly realistically works? Is it through Java or Pig or Hive?
Majority of the organizations, I can say every organization, will work on top of datasets using Hive or Pig.
Mm.
Because the thing is, if you just go for Hive and Pig, the most easy approach of processing the datasets the lesser span of time.
And number of lines of code also, right?
Obviously,
Mm.
obviously, because I can say in pig perspective, if you define 3 lines of code, almost you can generate 3 to 5 lines of code. You can generate almost 4 to 5 map reduce jobs. Where in the single map reduce job itself, while designing, we are just designing almost thousands of lines of code.
Yep.
So that will be a tricky task.
But the performance will be slow though, right? Because all the pig language has to be interpreted into MapReduce again, right? Isn't it?
No. Because pig has dual optimizers. Pig itself comes up with optimization techniques. You'll have something called as pig optimization at level 1, and you'll have another thing called as MR job optimization in pig. And apart from those, we ourselves will adopt some optimization techniques. So definitely you'll not find any performance difference between them. More or the same. But regarding the complexity, let's say if your data sets are so complex and if you want to handle some situations, then pig and hive might not suit at all the cases.
There are some problems.
Yes. Then you need to definitely come down to MapReduce job, or again you need to define a UDF for there. Again, UDF in Java.
Yep.
So that's where the challenges will be.
Yeah, we can never let Java go, I think. It has to be there.
So just 1 second. Somewhere I need to have this. Just 1 second. Right. So let me run on top of this. Initially, desktop. So here I have all the data sets. Dump.txt. This is my input file. Now let me upload this to HDFS. Yeah, I have all my services running on name node, data node, job tracker, task tracker, secondary name node. So let me verify that. Let me run them. Let me upload the data. I'm uploading with this name, URL dump. With that name, I'm just uploading all these data sets to HDFS. Let me verify that whether it was uploaded or not. So Here we have that. Huh. URL dump. So I have the data here. Now let me I have my data ready. So I'll just remove all the class files to make the things clear. So now let me compile them. Just compile them. Now I have the class files even ready and even the jar file. Now let me trigger the job. Input file name is, I hope I uploaded it under the name URL dump. URL underscore
Yeah,
dump.
URL underscore.
URL underscore dump.
So I'm just trying to store the output under the directory URL underscore REC.
Did you have these Java files in a folder or?
Yes, I made
Okay.
them in a directory actually.
Okay.
And I have something like job ID. I'll show you how to kill the job as well. Let this job run for this attempt. I'm gonna kill for the next thing, for the next attempt. Mm, 0KB. Just 1 second. Something wrong. I'm sorry. Just give me a moment. There's something mistake that happened. Here is the problem. So the output is the URLs are delimited by space, and I'm just splitting it by comma. So that's where the problem was. But in the code, whatever I shared, it is comma space only. but somehow I might have changed it here. I'm sorry for that. I'll just re-trigger it. Just give me a moment, please. I'm gonna share it, save it as URL op enough. Now let's see the output. The statistics, early statistics itself, it shared that map output records equals to 0. That was my mistake. I changed something in that earlier. Right. So you got the output. Where this is the combination. These both URLs is the combination, separated by comma. You can see that with 6 times repetition, with 7 times repetition, because this is a small file. Right? Am I clear? Hello?
Yeah.
Yeah, I think so.
Right?
Yeah.
Now let me show you how to kill this job, where we can use the help of, we can seek the help of logs to trace out the problem. So I'm just triggering the job. I'm just mentioning the output directory name as killed. Okay. So parallelly, I'm just opening, I hope everyone could see the screen, right?
Yes.
Parallelly, I'm just opening one more terminal, because before my job was getting triggered, I should kill it before it reaches 100% of the reducer. So I'm just so if I just trigger the job, I'll have the job ID, right? I'll have the job ID for each and every attempt. It will gonna give me the job ID. Job ID is 005. Now let's see. I'm just killing this job. The same job ID. Now it will pop up with an exception in this terminal. It should pop up with an exception. Yeah. Job failed. Job failed. So let's see the output. You did not get the output part 00 because now let's trace out in the logs history. I'm just tracing it out. So you'll get the best at last always. Last it will just give you the complete job report. Job ID equals to job. Finish it time this much. Job status equals to killed. Using these logs, you can even trace out the problems like this. So logs gonna help you. What happened and all the things. Right? Am I clear or anything unclear? Please. Or anything clumsy? Please kindly let me know. You can unmute yourself and you can shoot me.
I mean, I think the flow is clear. I think the initial couple of minutes I joined late. So the objective of this was to find the same person has clicked on two links, is it? Like how many times that person has clicked on two links? What are we trying to get from the log files here?
From the URLs.
Yeah, from the URL, sorry.
The major reason is, let's say we have the people who usually visit the things. People majority don't buy the things, they usually keep on visiting. If they were the buyers, definitely they'll have they need to provide all the information where the Flipkart or any e-commerce site gonna trace out all they'll preserve the information, and using that information, whatever they just provided, they can just pop up with the sophisticated recommendations, because they'll have user group, I mean user gender, they'll have user group, I mean age group, user place, location. So you'll have all those things, and basing on the taste algorithm, they'll just come up with all those things. But when there were viewers, only what all they can trace out is just by the click streams, whatever they make. So majority of the users, those who have viewed t-shirt also viewed something like jeans. Whoever viewed jeans also viewed something like shoe. So they're basing on that, they're gonna just trace out the things. So this is for those who were unregistered. Right?
Okay, got it. Thanks.
Yeah. So this is how we can just trace it up. And tomorrow, I mean on Monday, we'll talk how to index the data sets. We'll process 43 files at once, giving them as input. We'll process a directory in MapReduce, and I'll talk more clearly what was the objective, because that was the most important engine. Indeed, I can say that's the backend of Google. We'll talk about it, how exactly the pages will be indexed. Right? Yeah, please.
Yeah, Vignesh, I have one question here. If you don't kill the process, will it keep on running in the background, or will it be? Is there any time limit, like it will be should be killed after some?
Once after your job was finished, once after your reducer were finished,
okay, it automatically kills.
There is nothing like kill. The concept of killing is abstracting your job flow.
Okay.
If you don't kill it, job will be completed. That's it.
Okay.
Catch the point?
Yeah, I got it.
Yeah.
You were just showing us how we can kill a job if needed.
Yes. Huh? Yes. Okay. Yes. Yeah. Okay.
Hi, Vignesh.
Please tell me.
Currently, like the driver class, mapper class, retriever class, this Java classes